All right, welcome to the first day of Law of Sines. We're going to kind of develop the law of sines here for a quick moment. We're going to look for a relationship between the sides and angles in any triangle. We know what the relationship is when we have a right triangle. The relationship between all sides is the Pythagorean theorem. But we can't do that when we talk about a just generic triangle. So today, the first thing we're going to do is try to figure out what the relationship is. And I'm actually going to start by creating a right triangle. Okay, so let's create a right triangle here by dropping an altitude or a height in the triangle from angle C. Now, if we look just at the triangle on the right, let's just focus our attention here for a moment. We have this blue triangle, and if I wanted to, I could write the sine of angle B. And the sine of angle B, well, okay, let's call this H because we don't really have a name for that line. We want to be able to use it though. Sine of B would be the opposite side, H, over the hypotenuse, which in this case is A. All right, so what if now I focus my attention on this triangle on the left side? So now this green triangle. Now what if I ask you to write the sine of A? Okay, well the sine of A would be the opposite side, H, over the hypotenuse of that triangle, which is B. Now, what if I solve both of those for H? In other words, in the first equation, I'm going to multiply both sides by A. So I get A times sine of B equals H. And then if I multiply both sides by B here, I will get B times sine of A is also equal to H. Let me just move that H to more of the center here. So now I have two things that are equal to each other. So I have A times sine of B equals B times sine of A. Well, what if I divide both sides by AB? I'm going to get some giant ones here. Oops, not that one, that one. And what I end up with is something that looks hopefully familiar. Sine of B over B equals sine of A over A. And if you notice down here, that's exactly what I have written. It's called the law of sines. Now we could do this whole thing again and get that sine of C over C is equal to maybe sine of B over B, and then we'd have that all three are equal to each other. But this is how the law of sines is developed. So when are we going to use the law of sines? All right, the law of sines can be used to try to find the measure of a side or the measure of the angle. But here's the key. In order to find either of those things, I have to know at least one complete ratio. In other words, I have to know both an angle and a side across from that angle in the triangle. Otherwise, I cannot use the law of sines. So looking at my first triangle here, I have angle B, whoops, I lost my highlighter. Angle B is 29 and little b is 28. And then I know that angle C is 102 degrees. So if I wanted to find A, well, that's this here. I need to know the angle across from A in order to proceed. Do I have a way to find the angle across from A? Well, yeah. I mean, I know two angles in a triangle. So I know 102 and 29 plus angle A have to add up to 180. So that gives me a way to find angle A. So I get 131 plus angle A equals 180, and you can do this a lot faster. I'm just making sure we see exactly how to do it here. So that gives you 49 degrees. So now we can actually use the law of sines. So what we will do is we'll take one complete ratio, and by that I mean something that you know both parts in. So that would be, for example, sine of B and angle or little b. And then we take the side and angle that we're trying to find. So sine of A over little a. And then I'm just going to fill in the measurements that were given. And then at that point, it's just a matter of solving that for little a. So I'm going to start, since we have a proportion here, by multiplying the cross product. So I'm going to multiply A times sine of 29 equals 28 times sine of 49. And then again, I want to solve for A, so we're going to divide both sides by the sine of 29. And that's going to give me an expression that I can then say that's what A is. So A is going to be 28 times the sine of 49 over the sine of 29. And then this is when you would need your calculator. Now we're going to get an approximation here. It will not be exact, so we want to make sure we use the approximation symbol. Go ahead and type this into your calculator. A couple things. Make sure you're in degrees. And let's round to the nearest tenth. So type this into your calculator and see if you get the same thing I do. And you should get about 43.6. Okay, that would be the length of A. If you did not get 43.6, make sure you ask me about that in class the next time you see me. But careful with closing parentheses around the angle once you type in the sine. And you can do it in multiple steps if you'd like. All right, let's try one more. So now we're going to use law of sines to find the measure of an angle. So again, I'm going to kind of highlight the things that go together. So the sine of C, which is 112, will be divided by 10. And I'm trying to find angle B, and that's across from angle, or little 7. So I'm going to write this without writing the actual law of sines property out first. So I would have the sine of the angle, which is 112, divided by the side across from the angle, equals, now I don't know what angle B is, that's what I'm trying to find, so it'll be sine of B over 7. And then once again, we'll go through our cross multiplying and solve. So I'll have 7 times the sine of 112 equals 10 times the sine of B. I need to solve for B. First thing I'm going to do is divide both sides by 10. Okay, now that's going to give me 7 times the sine of 112 divided by 10 equals the sine of B. And let me actually write that a little bit differently here. I'm just going to give myself some space. I don't know why that's being so weird about erasing. So I'm going to write that as a sine of B. Now, we want to figure out what B is. We have to undo sine. So the way we undo sine, and hopefully remember this from your geometry days, is by using what we call the inverse sine. And I'm going to take the inverse sine of both sides. And what that does, the inverse sine undoes sine, and we're just going to be left with B. Once again, we're going to type this into our calculator. You can do it in steps if you need to. Inverse sine is found by doing second sine. Go ahead and try it. Come back, check your answer. Round to the nearest tenth again. And hopefully you get about 40.5 degrees. What I would like you to do right now is go to the website that you see on linked here. I will also post this on Classroom so you can access it pretty easily from Classroom. I think it'll also be in our calendar for the week. Watch this video, it's pretty quick. I know that it's a little cheesy, but just bear with me and come back when you're done. So what you saw in the video summarized are that when we encounter this ambiguous case, there's actually 3 possible outcomes. We might be in a situation where we cannot create any triangles based on the lengths of the sides and the angle that we're given. We may be in a situation where we can create one triangle that is a right triangle, or one triangle that is a non-right triangle. We can also end up in a situation where we could theoretically have 2 triangles because the side A is long enough that it can swing outward, but it's also short enough that there's space still to swing inward. So we have 3 different possible results. There could be 0 triangles, 1 triangle, or 2 triangles. So when does the ambiguous case become an issue? It becomes an issue when you're given an angle and 2 sides. And we have a very specific situation here where the angle is not included and the side that's opposite the given angle is the smaller of the 2 sides. So the angle is not included and the side opposite the given angle is the smaller of the 2 given sides. So just for a moment, let's look at these 3 triangles and figure out whether or not we are in the ambiguous case. So in triangle B, okay, Here's our angle that we're given, angle 110. If we look at the two sides that we are given, this side and this side, the angle is not in between those two angles. The angle is not here. Therefore, it's not included, which is what we want in order to be ambiguous. Now, the second piece of information is that the side opposite the given angle is the smaller of the two sides. So when I look at the side that's opposite the given angle, 55, it's not smaller than 20. So because it's not smaller than 20, this will not be ambiguous. We will only be able to get one triangle from that. All right, let's try another one here. So identifying our angle, angle's here, and then my two sides, 23 and 30. Since my angle is not in between the two sides, it's not here, it's not included, which is one way to check for ambiguous. Now, the second condition is that the side opposite the given angle is the smaller of the two sides. So across from this angle is 23, and that is smaller than 30. Therefore, this is ambiguous, which means we could have 0, 1, or 2 triangles. And then finally, let's try the last one here. So here's my angle, 115. Here's one side. Here's another side. And this time my angle is included. It's in between the two sides that I'm given. Therefore, this is, right off the bat, we can say this is not ambiguous. Okay, so what do? When we encounter the ambiguous case, first, you find an angle just like you would normally, okay? If you get an error in the process of finding the first angle, that means that there is no triangle possible, and you're done. So that would be our 0 triangles in our ambiguous case. If you are able to find an angle measure, that means that there's at least one triangle, but there might be 2. And the way we figure out if there's 2 is we find the supplement of the first angle that we found. If we find an angle that will work in a second triangle, then we'll get a second triangle. If it won't work, then there's only one triangle. And this will make more sense as we go through it. If we get a second triangle, then we're going to find both triangles and then finish finding any missing sides and angles in however many triangles that you have. Okay, so let's look at the problem from example 1 that might have been ambiguous. So we have our angle, we said was 46, our side, and since it's not, the angle's not included between the two sides, it's over here, and the side across from the angle is the smaller of the two, this could be an ambiguous triangle. So I'm going to set this up just like I would normally. I'm going to look for, and I'm actually going to change this now to red so that I can set up my pieces here, and then this would be blue. I'm going to find the only piece of information that I can find to start with, and that's going to be the side across from 30 degrees. Now, before I get started, I'm going to go ahead and label this triangle A, B, and C, and then little a, little c, and little b, just so we have a way to put things into our law of sines formula. So I start with the thing that I know both parts of, and that's C. So I'm going to start with setting up my sine of angle 46 over little c, which is 23. Now that's going to be equal to, well, the only thing I can find here is angle A, because I only know side A. So I have to set this up as sine of A over 30. Okay, now I want you to pause the video, solve this just like you would, like we did on the previous examples. Multiply your cross products, and you'll eventually have to use the inverse sine. So go ahead and try that, come back and check your answer. Now, I think I told you on the previous slide to round to the nearest tenth. If you did, you would have had 69.8 degrees, but I'm going to go ahead and round this to the nearest whole number just to make it easier for us. So we get that angle A is 70 degrees. So since we've determined that this is an ambiguous case, here's where we start to then do things a little bit differently. So the first thing I'm going to do is I'm going to just assume that there is a second triangle, all right? So I'm going to draw myself a triangle that looks exactly like the triangle I started with, or as close to that as I can get. And I'm going to put all of those things that I was given initially in that drawing, all right? So I have little a, little b, and little c, all right? So it's an identical triangle. Now, what I do is, let's call these A prime, B prime, C prime, just because that gives us a way to kind of talk about it being a different triangle. that confuses you, just call them A, B, and C, not a big deal. But A prime, so the angle that goes in the second triangle, is going to take whatever we just found and subtract it from 180. So A prime actually ends up being 110 degrees. So that would be the first new piece of information that I would get in this triangle. Okay, now I'm just going to keep solving the two triangles like I would normally. I want to at least get you through the first angle, the second angle that we would have to find in each triangle. So in the first triangle, triangle 1, I would find angle B by adding 70 and 46 together and subtracting from 180. And that's going to give you 64 degrees. So we got 64 degrees. Okay. In triangle 2, again, I will take 110 plus 46 and subtract it from 180. And that's going to give me 24 degrees. So no issues here. This is where you would encounter your issue if there's going to be one. All right, so I've got a little b in both triangles left to find. I want you to go ahead and pause the video. I'll set the equations up for you. Okay, so in triangle 1, we will have our law of sines would say we'd have, I always just go back to what I knew initially, sine of 46 over 23. Equals, and this time I need to find angle little b. So I'm going to choose to work with sine of 64 over little b. And now you can solve that equation. In triangle 2, same kind of idea, right? I've got, and if you need to, you can highlight things like you did in the first triangle, just so you know what corresponds with what. I've got sine of 46 over 23 equals, and then I'll have sine of 24 over b, and then I can solve that equation. So pause the video here, try it out, see if you can find what b is in both of those triangles. You'll find that I normally round angles to the nearest whole number and sides to the nearest tenth. And what we'll get for little b in the first triangle is 28.7 approximately. And little b in the second triangle will be 13.0. If you had trouble getting either one of those, make sure you ask about it in class. All right, example 2. This time I'm going to go ahead and highlight the things that correspond to each other. Okay, and I've got this angle will correspond to this side, and then we'll do green. I did that backwards. This angle on this side. Now I would also label them. So we have little p here, little a here, and what is that? Little r. Okay. Now I've got my first triangle. So I'm going to set it up using law of sines. So I have the angle 31. And I know across from angle 31 is 11. So that's my first law of sines ratio. And then the only thing that I can find here is angle A, because I know little a is 24. So I set this up, and then we need to solve for A. Once again, I'd like you to try this, so pause the video, try it, and come back and check your answer. Since we're finding an angle, you can go ahead and round to the nearest whole number. So you guys probably encountered a problem here. Right off the bat, when you try to do this on your calculator, you get an error message. And here's why. If you just type in 24 times the sine of 31 divided by 11, you get the inverse sine of 1.1237-ish. Now here's the thing. The inverse sine cannot, if you're finding the inverse sine of a number, that number cannot be bigger than 1. So, and that all goes back to being part of a unit circle when we're finding our trig values. So what happens here is A is not possible. Now, remembering that this is an ambiguous case because our angle is not included between the two sides we know, and 11, which is across from the angle we're given, is the smaller of the two sides. So this is an ambiguous case. It is possible that we could have no triangles. So because A is not possible, we would just say there's no triangle possible here. All right, last example for today. Now this one does not have a picture. So the first thing I'm gonna do is I'm gonna draw a picture. And I just draw a random triangle. I'm gonna label it ABC and label the little sides, or the sides with the lowercase letters. And then just fill in what I'm given. So I know that angle B is 30 degrees. I know little b is 20, and I know little c is 40. First thing I'm gonna do is check to see if we have an ambiguous case. So this angle and this side, well, okay. The angle's not included between the two sides that were given, right? It's here instead of here. And if we look at the side across from the angle we know, that's 20, it's smaller than the other side. So this is ambiguous, okay? So we're in another ambiguous case. So let's go ahead and see what we can do. First thing I'm gonna do, let me go ahead and highlight some things to help us here. Just keep our sides and angles all corresponding. First thing I'm going to do is set up the only law of sines that I can actually solve here, which would be using sine of 30 degrees over 20 degrees. And then I have to solve for c first. So sine of angle c over 40. Go ahead and solve that and come back and check your answer. And again, round to the nearest whole number. So hopefully you got 90 degrees for C, and you should have gotten exactly 90 degrees. All right, so we have 90 degrees. Now, if I put that on my triangle, if this is 90 degrees, then I can pretty quickly find out that angle A is going to be 60 degrees. Now, with that 90-degree angle, if I were to draw a second triangle, so let's say I draw this second triangle, okay, like we talked about earlier. And I have angle B, angle C, angle A. So putting in all that information I had to start with. And then I take that first angle that I found, C, and I subtract it from 180. Well, I'm going to get 90 again. So I end up with exactly the same triangle again. So there's really only one triangle. I don't have to worry about finding the information for a second triangle. Now, there is one side left to find, and that is side A. So we'll set up that equation. Okay, so I go back to what I originally had, which was sine of 30 over 20 equals, and then I'm going to use angle A this time, so sine of 60 over little a. And then I can solve that. Now here's the thing. You could use law of sines here, but maybe you're recognizing that this is a 30, 60, 90 triangle. And even better, maybe you remember that the side across from 60 is just the shorter side times radical 3. So you could probably just do 20 times radical 3, and that should come out to be approximately the same thing you get when you solve it for A using law of sines. So go ahead and pause the video, find A using law of sines, come back and check your answer. All right, so we should get A is approximately 34.64. And guys, if you type in 20 times radical 3 in your calculator, that is also 34.64. Sorry about the bell in the background. Okay, so that is law of sines. Now, some of this you've seen before. And the ambiguous case is something new. So remember, ambiguous case just means there could be no triangles possible, there could be exactly one triangle possible, or there might be two triangles possible. And your job when you figure out something is the ambiguous case is to make sure that you find all possible triangles. All right, you can ask your questions in class. I'll see you then.